Hello students, how are you all? I hope you are doing absolutely well. We are at AriserTalent and I am your chemistry teacher. So we are on the first chapter of our chemistry, that is chemical reactions and equation. So in our previous lecture, what we have gone through is we have discussed about the chemical reactions and we have discussed about first reaction, that is slow and fast reaction. Second category of the reactions we have discussed reversible and irreversible reaction, and the third category of the reaction is exothermic and endothermic one. So we will do the quick recap of all the reactions. Second category is reversible and irreversible. What we have seen in this reaction, the reaction that may be proceeded in both the directions are known as reversible, and which can proceed only in single direction is known as irreversible one. Second category of the reactions is endothermic one and exothermic one. In exothermic reaction, the energy or heat is released or evolved out, but on the other hand, endothermic reactions are those reactions in which the heat is absorbed. Now we are on the third category of our reaction, that is known as combination reaction. So our third category is combination reactions. So, combination reaction, as the name signifies, in this reaction, the two elements or the two substance combine to give a particular type of product, and the combination reaction is sometimes also known as addition reaction. So, our first point is these are called addition reactions. Second point is these combination reaction are formed by the combination of two or more elements to give the compound. In this reaction, two elements or substance react to give product. So this is the second point regarding addition or combination reaction. What happens in this reaction? Firstly, these reactions are known as addition reaction because it is formed by the addition of two or more elements. Now, two elements or substance combine to give only a single product. It means in addition reaction, what we have obtained, we can obtain only single product. So, the third point is only single product is obtained. So, this is our third point regarding combination reaction, that we have got only the single product. Now, in our previous lecture, we have discussed about the combination reaction can be of the several types. So, what are the specifications of these reactions? We have different categories. And the different categories for the combination reaction are: first, the reaction can be element-element. The reaction can be compound-compound. And the reaction can be element compound. So, here is a three classification or the categories of the addition reaction, that these reactions can be element-element type, Second, it may be compound type, and the third category is it may be element compound type. So we will discuss the three categories one by one, but firstly we will discuss about the combination or addition reaction with the help of a simple diagram. So what we have seen here, see here, we are provided with two elements or substances. This is element number 1 and this is element number 2, or we may call it compound 1 and compound 2. And after the combination of both these, what we will get here, we will get A and B. This is only a single product that I have told you, we will get only a single product in combination reaction. Now, this is a basic representation of the combination reaction. We will consider about the examples of the combination reaction. So we have certain examples. So our next topic is examples of addition reaction. What happens in case of addition reaction? H2 plus Cl2 gives 2HCl. H2 here is hydrogen, Cl2 here is chlorine, and 2HCl here is hydrogen chloride. So this is a general example for addition or combination reaction we have discussed here. So what we can conclude it from this type of the reaction, see here, H2, that is an element, Cl2, this is again an element but it is non-metal. H2 and Cl2 both combine with each other to give a particular product, and the product obtained is only one. So this type of reaction is considered in the category of combination reactions. Now, if in combination reaction the product obtained is only from its constituent elements, we can call it as a synthesis reaction. So we have next category, that is synthesis reaction. So we are again with our new term, that what is synthesis reaction. In synthesis reaction, the product obtained will be from its constituent elements or components. So if product obtained from constituent components, the reaction are termed as synthesis reaction. So look at the example, H2 and Cl2 will give us hydrogen chloride. So in the product side again we will get H and Cl. So the product obtained here will be from the constituent elements. So we can say that this is a synthesis reaction. It means all addition reactions are synthesis reaction, but all synthesis reactions are not addition reaction. So one point here to be noted is, we may consider it as a note, all addition reactions are synthesis, but on the other hand all synthesis reactions are not the addition one. So this is a general note about the addition and synthesis reaction. Now we have learned about the addition or combination reaction. Now we will deal with the element-element combination, compound-compound combination and element-compound combination. But before that, if you want to copy this, please copy it now. So we will deal with the type of the reactions of element or compound in combination as follows. Firstly, we will discuss the case about the element-element combination. So our first set of reaction is element-element combination. So in element-element combination, what we have seen is one element combined with other element to give a particular type of the product. So we have an example in this category like Mg plus O2 gives MgO. This is an element, oxygen is another element, and particular type of product is obtained. If I am going to balance this equation, what we will get? We will get 2 MgO. Here Mg is magnesium, O2 is oxygen, and the product we obtained is magnesium oxide. So this is about the combination of element-element 1. So we have discussed our first category, that is element-element reaction. Now we will deal with our second category, that is compound-compound reaction. So our second topic is compound-compound reaction. In compound-compound reaction, we have both the reactants in the compound form. So we have a general example for this. What is the example in this category? Ammonia react with hydrochloric acid to give ammonium chloride. So students, see in this reaction, we are provided with one compound, another compound, and the product obtained is again compound. So here NH3 is ammonia, plus it reacts with hydrochloric acid, and the product we have obtained in this equation is ammonium chloride. So this is a general equation for compound-compound relation. Now element-element reaction we have discussed. Second category is compound-compound reaction. Now we are on our third category. This will be the last category, and the reaction is element-compound. So the third category is element-compound. So in the category of element-compound reaction, what we have taken is, we have taken O2 react with CO2 gives CO3. So O2 here is an element, that is oxygen. CO2 is carbon dioxide, and what we have obtained here is, it is carbon trioxide. So this is the general example for the element compound combination. So I hope from these examples addition reaction will be clear to you. Our first example will be for element-element, second will be for compound-compound, and the third example we have discussed is element-compound, in which we have taken one element and one compound. And now in our today's lecture, we have proceeded with the different type of chemical reaction. But firstly, we will do the quick recap of our previous topics. That is, in types of chemical reaction, we have already discussed about slow and fast reaction, reversible, irreversible reaction, exothermic and endothermic reaction, and our last category we have discussed about the combination reaction. So what actually the combination reaction is? In combination reaction, the two elements combine to form a single product. It means element A and element B combine to form a single product. In this category, we have discussed about element-element combination, compound combination, and we are left with one combination, that is element compound combination. So our third topic is element compound. So what happens in case of element compound reaction? One element react with compound to give a particular type of product. So first element I have considered is O2. Second compound I have considered carbon monoxide, and CO2 and O2 react with each other to give CO2. Here O2 is oxygen. This is carbon monoxide. And this is carbon dioxide. So we can see that one element combined with compound to give a particular product, and this is the category of element compound reaction we have. So this is an example for element compound reaction. We have also discussed about the synthesis reaction, that synthesis reaction are those reactions in which a compound is formed from its constituent components. So we have a basic note here, that is all synthesis reactions are addition. But all addition reactions are not synthesis. So here is our second point. All addition reactions are synthesis. So this is the main criteria about the combination reactions we have discussed. This is all about the combination reaction and addition reaction. Now we are proceeding to our fourth category of chemical reactions, that is decomposition reactions. So our next category is decomposition reaction. So we are on our second category of chemical equations, that is decomposition reaction. Decomposition reaction means a product decomposed into two or more components. So in the reactant side we are provided with only one component, and in the product side we will get two or more reactants accordingly. So in the decomposition there will be a breakdown of a particular product. This can be understood by the help of this suitable example. Suppose I have NaCl. In this I have chlorine atom and sodium atom. These two combine to give the particular product, that is NaCl. Now what we will see, after decomposition I will get for one molecule of Cl and one molecule of Na over here. So NaCl decomposed to give Cl and Na. So this is the basic equation for the decomposition reaction, that AB, that is a particular product, give two components, that is A and B. So what happens in the case of decomposition reaction? The compound disassociates into two elements or components. So in this reaction any compound get dissociate into two or more components here. So this is about the decomposition reaction. But we have discussed the category. In decomposition reaction there is a three application that it can be done by the application of heat, it can be done by the application of current, or it can be done with the application of light. So we have the three categories in the decomposition reaction. Our first category of the decomposition reaction is thermal decomposition. Our second set of the reaction is electrolytic decomposition. And our last set of decomposition reaction is photolytic decomposition. So here are our three categories of the decomposition reaction, that is thermal decomposition, electrolytic decomposition, and the last one is photolytic decomposition. Now we will deal with these three categories one by one. So our first category here is thermal decomposition. So what happened in case of the thermal decomposition? A compound dissociates into two or more element by the application of therm. Therm means heat. So here heat is applied in this reaction. Electrolytic means electric current is used for the decomposition of these kind of reaction. Last category is photolytic. Photolytic means photons are used, and photons may be formed in the form of sunlight for the decomposition of this particular type of reaction. So we will deal with all these three categories one by one. If you want to copy it, please copy it now. Now we have the three categories of the decomposition reaction that we have dealt with one by one. Our first category is thermal dissociation, or we may say that thermal decomposition. So thermal decomposition is the decomposition in the presence of heat. So its major definition is compound dissociates in the presence of heat. Therm basically means heat. So here the product or the term that we have to consider is heat, because the thermal decomposition will be done in the presence of heat only. Now we will consider the example for thermal decomposition. We have one example here. Suppose we are provided with calcium carbonate and it does dissociate into calcium oxide plus carbon dioxide. This is the basic reaction we have. Now what we will see here, CaCO3 is calcium carbonate. What is CaO? CaO is calcium oxide, that is slacked lime. CO2 is what? CO2 is carbon dioxide. So CaCO3 will get decomposed into calcium oxide and carbon dioxide only in the presence of heat, and this is known as the thermal decomposition. The sign we have indicated here will be for the thermal decomposition. So on the shorthand notation, we can say that these reactions are accomplished only in the presence of heat only. Now we will deal with our second category of the decomposition, that is electrolytic decomposition. Our second category is electrolytic decomposition. So, what happens in the case of electrolytic decomposition? As the name indicates, electric current is applied for the decomposition of the particular component. So, our next topic is electrolytic decomposition. So, what are the points to be considered here? Compound decomposed into elements in the presence of electric current. So, here the application of electric current is used for the decomposition of the particular type of the product. So, what factor we have to consider here is electric current. Now, we will have another example in this category. What I have taken a water in the aqueous form and I have to dissociate into H2 and O2. What will I do? I will pass direct current to it. So, we have an example of dissociation of water. We are given H2O. H2O will break into H2 plus O2. This reaction is not balanced. Firstly, we will balance this equation. We have provided with 2 O2 atoms. So, we will balance by putting 2 over it. And again, we are getting 4 hydrogen here. So, again substituting 2 over here. Now, this equation is completely balanced. What we will do now? Here we have water. This is hydrogen gas. And this is oxygen gas. So, on passing direct current to the water, the products we have obtained after the decomposition as hydrogen and oxygen, and this will be done only in the presence of electrolytic decomposition. So, what we can write on this arrow? We can write here electric current. In case of the thermal decomposition, we have provided heat, so we will indicate it by this arrow, and here we have write electric current. So, this is the decomposition of water in which we get hydrogen and oxygen in this reaction. Now, we have one more example for the electrolytic decomposition, that is we have 2 NaCl. This NaCl will be in molten state. If I pass electric current through it, it will dissociate into Na plus Cl2. So, what we have done the dissociation of molten NaCl, and what we will get sodium and chlorine. So, here products are sodium and chlorine. And what we have done? We have passed electric current through it. So, this is another example for electrolytic decomposition, that the decomposition will be done in the presence of electric current only. Now, we are with our last category of the decomposition reaction, that is photolytic decomposition. But before proceeding to it, if you want to copy it, please copy it now. Our third category of chemical reaction is photolytic decomposition. So the term indicates photo. Photo means in the presence of sunlight or in the presence of light or photons. So this decomposition will be basically done in the presence of sunlight and photons. So the term we have to consider here is sunlight and photon. Now for the photolytic dissociation, we will consider an example. We have an example in this category. Suppose we have to dissociate silver bromide, that is AgBr. Now what we will get on the product side? We will get Ag plus Br2. This is silver bromide. Ag is for silver and Br is for bromine. So this is a general equation representation for the photolytic dissociation here. So this dissociation will be done only in the presence of light. So we may call it photolytic dissociation because here light is used. So on the arrow we can use light. So it is all about the decomposition reactions. So it is all about the decomposition reaction. Now in the decomposition reaction, we have one more term, that is analysis reaction. So analysis reactions are those reactions in which after decomposition, the product obtained on the product side will be of the same, that is of the component elements. So we have our next category, that is synthesis reaction and analysis reaction. So what are analysis reaction? In this reaction, after decomposition, we will get same components. So this is the definition for analysis reaction, and this will be more clear to you with the help of an example. Suppose I have provided with hydrogen iodide. Suppose we have 2Hi and we have performed the decomposition reaction for it in the presence of H nu. What we will get? We will get H2 evolved plus iodine gas, which is also evolved. So 2Hi here is hydrogen iodide. H2 we will get here is hydrogen. This reaction is done in the presence of H nu. H nu means in the presence of light. And I2 we have got here is iodine. So what we have seen in this example, the hydrogen iodide decomposed to give hydrogen and iodine, that the product we have, we will got the two components which are same as that of the reactant side, that is H2 and I2. So we may say that these type of reactions are known as analysis reactions. So again we have with a term that all decomposition reactions are not analysis reactions, but all analysis reactions are decomposition reaction. So again we have one note, that is all analysis are decomposition, but reverse is not true. It means all analysis reactions are considered in the category of decomposition reaction, but all decomposition reactions are not analysis. So this is a major point of consideration here. So it is all about the decomposition reaction. Now we are with the third category of the reactions, that is displacement reaction. So now we are with our next category of the reactions, that is displacement reaction. So our next category is displacement reaction. Again, in the displacement reaction, the name indicates one element or the constituent element get displaced by the other. So in this type of reaction, one active element will displace the less active element. So what is the definition for the displacement reaction? In this type of reaction, constituent element get displaced by other element. So this is all about the displacement reaction, and the second point we have to consider is more active element displace less active element. So this is all about the displacement reaction. We have that there will be a displacement of two constituent element in which more active element, the element which is active according to the reactivity series, will displace the less active element. Now we will understand with the help of a suitable example what we have. We have provided with any element A. Now we have another element, that is B and C, and what we will see in this reaction, we are provided with A and BC, and we see that B is less active and C is more active. So the C react with A to give the product AC, and B will be displaced in this kind of reaction. So if I consider this example, I have seen here A is reacted with C because C is more active and it replaces B. So we can say that C is more active and B is less active. So if the C is more active, it displaces B from the solution, and the component we will get here is AC. So this is about the displacement reaction. But again, in the case of the displacement reaction, we have many more categories, that is displacement of metal by metal, non-metal by non-metal, and displacement of metal by any acid. So in this diagram, we have seen here that I have already told you B is less active metal, so C will take the combination of the with A, and the compound AC will be obtained in this reaction, and B will get displaced from the solution. Now let us consider the example for displacement reaction. We have provided with AgNO2. AgNO2 is basically silver nitrate, and what we will see in this reaction, if it get reacted with NaCl. NaCl here is sodium chloride. Now we will understand the displacement with the help of an example here. In this category we have taken a AgNO2. AgNO2 is basically the silver nitrate, and the silver nitrate got react with NaCl, that is sodium chloride. So Na will react with Ag, and in this case Ag and Na will show the simultaneous reaction, and what we will get on the product side is AgCl and NaNO2. So if I consider both these cases, Ag will react with chlorine and Na will react with NO2. What happens in this reaction? In this reaction, there will be the displacement of the ions, and the displacement of ions will be done on the basis of their reactivity. Ag will react with silver to form silver chloride, and NaNO2 will be formed as sodium nitrate. So these are the two products we have obtained in this equation. Cl is more active as compared to sodium, so Cl will combine with Ag, and Na is less reactive as compared to it, so it forms a reaction with NaNO2, and here we will get the two components, that is AgCl plus NaNO2. So what we have seen in this type of reaction, we will see there is a displacement of more than one ion. What we will see? Displacement between two constituent elements. If there is a displacement between the two constituent element, we will categorize it into the category of double displacement. We have two type of displacements, single displacement and double displacement. Here we have reacted two components and there is an exchange of elements between the two components. So it is considered in the category of double displacement reaction. So this will be the example for double displacement reaction. So it is all about the displacement reactions. This lecture is over for today. We will deal with many more equations in our next lecture. Thank you so much and have a nice day.